You know, we've all done it, right?
Oh, absolutely.
Reached into a bag, pulled out that perfectly crisp, little salty disc, and just crunched away
Yeah.
without really giving it a second thought.
Not at all.
I'm talking, of course, about the potato chip. It's so, well, it's everywhere, isn't it?
Completely ubiquitous.
So iconic. But have you ever, actually stopped to think about the incredible journey that little thing takes?
It's quite something.
From, deep in the ground through this amazingly complex, high-tech process all the way to your mouth.
Yeah.
It seems so simple. Potato, oil, salt. That's it.
Most people think.
But as we're about to get into in this deep dive, there's just this whole universe of precision and technology and some surprising science packed into every single chip.
You're absolutely right. And our mission today, really, is to peel back those layers, pun always intended there, and explore the really meticulous, often very high-tech industrial process behind, one of the world's most loved snacks.
Definitely love.
We're going to use this great stack of sources you've pulled together as our guide, try and pull out the most important bits of knowledge, the key insights.
Yeah.
And this whole deep dive, it's really for you, the listener, to get that essential info quickly, thoroughly, and hopefully, have a few aha moments along the way.
I hope so.
It's a pretty fascinating glimpse into the sheer scale and, frankly, the ingenuity of modern food production.
I have to say, I've always, enjoyed a good chip, but digging into the materials for this, I'm genuinely excited to uncover what I'm kind of calling the secret life of a potato chip.
I like that.
Because the scale and the precision needed for mass production, it kind of blows my mind. I mean, billions of chips made every year.
Billions upon billions.
And every single one needs to be pretty much perfect consistently. That's no small feat.
It's an engineering marvel, it truly is. And what's so fascinating, like you said, is that every single step, right from the moment a potato is even chosen from the field, it's all meticulously controlled.
Of every step.
Every step. There are these surprising scientific details that come into play, dictating everything from, say, the chip's final golden color to that undeniable crispiness. And even how long it stays fresh on the shelf. It's a process way more intricate than just, slicing a potato and tossing it in hot oil, as we're definitely going to uncover.
Okay, let's unpack this right from the very beginning, because it really does all start with the soil. And one detail that genuinely surprised me from our sources was this. You can't just use any old potato for a chip.
No, you absolutely cannot.
Does the type of potato really matter that much? Or can they just grab whatever's cheapest or, most available?
Oh, see, that's where it gets really interesting. And no, it matters immensely. This potato selection isn't just like a minor preference. It's basically the blueprint for the chip's final identity.
The blueprint. Wow.
Yeah, manufacturers don't just use any potato. They specifically look for varieties known as chipping potatoes. Often you'll hear names like Atlantic or Kennebec or sometimes specific russet varieties bred for this purpose.
Okay, so not the kind that bake or mash.
Exactly. These aren't your typical baking potatoes, definitely not your boiling potatoes. They're chosen for two absolutely critical characteristics, non-negotiable, really, for making good chips.
And what are those?
First, they need a low sugar content, and second, they need a high starch content, or high solids.
Okay, low sugar, high starch.
Oh.
Why are those two factors so crucial? What happens if they use a potato with too much sugar? Does it just taste sweet?
It's not so much about tasting sweet, but about how it reacts in the fryer. If a potato has too much sugar, those sugars caramelize. They brown way too much during that intense frying process.
Oh, okay.
And you end up with these dark, sometimes almost burnt-looking chips, really unappealing. Nobody wants those.
Right, you want that golden color.
Exactly. And the high starch content, that's absolutely vital, too. It provides this sort of structural integrity needed to get that perfect, uniform, satisfyingly crispy texture that we all expect.
Gotcha.
So this initial choice, this specific potato type, it's the foundational decision. It dictates the final look, the texture, and critically, that signature crunch. Without the right starch and low sugar, that perfect golden crunch just doesn't happen.
That's a level of agricultural specialization I just hadn't considered for something as seemingly simple as a chip. It's amazing.
It really is.
You picture these vast fields, right? Not just growing food, but growing the perfect ingredient for one very specific global snack. It's almost like a dedicated crop.
In many ways, it is.
And okay, so once these chosen ones, these perfect chipping potatoes, are ready in the field, how do they even get them out of the ground? Is it still people gigging them up, or is it something much bigger, more automated?
Oh, it's definitely way bigger and automated. At this kind of industrial scale, manual harvesting would be completely impossible. Way too slow, way too expensive.
Right.
Farmers use these really sophisticated mechanized harvesters, huge machines, specifically designed to gently dig the potatoes up from the soil.
Simply, huh? Even the machines.
Yeah, relatively gently. They lift them onto conveyor belts right inside the machine, trying to minimize any bruising or damage as they're collected. It's a very precise, large-scale operation, all designed to keep that raw material intact and in the best possible condition for the long journey ahead.
Okay, so they're out of the ground, carefully harvested, but they don't just go straight to the factory floor then, do they?
No, not usually.
I read something about a really crucial intermediate step, the way they're stored. What's so special about their storage? Can't they just pile them up somewhere cool?
You're right, there is a crucial storage phase, and it's far more scientifically controlled than you might guess for, a humble vegetable. These specialized potatoes, they're typically stored in very specific conditions. Cool, dark, and humid environments.
Oh, dark, humid. Okay.
Where we're talking precisely controlled temperatures, usually hovering around 45 to 50 degrees Fahrenheit. That's roughly, 7 to 10 degrees Celsius?
Pretty cool.
Yeah, and the humidity is also meticulously managed, kept quite high.
So it's not just a big shed then. It sounds more like a high-tech, climate-controlled root cellar, almost.
That's a great way to put it, like a massive high-tech root cellar.
But why? Why is that specific temperature and humidity range so incredibly important for a potato that's going to become a chip? What's the science behind that?
Well, it's all about preserving their freshness, yes, but crucially, it's about managing their internal chemistry. See, potatoes are living things even after harvest.
Right.
And if you store them improperly, especially if it's too warm or the conditions fluctuate, they can start to sprout.
Those little eyes start growing.
Exactly. And sprouting is a sign of a physiological change happening inside. The potato starts converting some of its stored starch back into sugars.
And we just learned sugars are bad for chips.
Precisely. Higher sugar content, as we just discussed, is the enemy of that perfect golden, crispy chip. It leads straight to that undesirable dark browning during frying. So this precise, carefully controlled storage environment, it actively prevents those pre-browning issues. It maintains that delicate chemical balance. Low sugar, high starch, ensuring the raw material stays in optimal condition, ready for processing. It's a really critical, though often unseen, step in maintaining product quality and consistency.
It's just incredible how much science goes into it before they even get to the factory. Okay, so we've got these specialized potatoes, harvested carefully, stored perfectly in their climate-controlled hibernation spots. Now it's time for them to actually go to the chip factory.
The big trip.
And our sources really hammer home the sheer scale of this. We're talking mass transportation. What does that actually look like? How many potatoes are we talking about?
The logistics are just staggering. When you picture a chip factory, don't just imagine like a couple of trucks pulling up each day.
Okay.
Picture a continuous stream, maybe dozens, sometimes even hundreds of these huge trucks arriving daily, sometimes 247 for the big plants. And each one of these trucks, these massive tractor trailers, can be loaded with an astonishing 40,000 to 50,000 pounds of potatoes.
50,000 pounds in one truck.
In one truck. So this isn't just about moving stuff from farm to factory. It really underlines the colossal volume of raw material needed to feed that insatiable global demand for chips.
It's mind-boggling.
It's a meticulously choreographed logistical ballet, really, just ensuring a continuous, unbroken supply for manufacturing lines that often run nonstop.
That's literally mountains of potatoes arriving every single day. It's hard to even visualize that volume. But surely they don't just get dumped straight from the truck into the processing line, do they?
No way.
I mean, with that kind of scale, there must be some kind of really rigorous quality control check right there at the factory gate.
You're absolutely right. This is a critical quality gate, absolutely non-negotiable. And it really shows the stringent standards in this industry before any potatoes are unloaded from those giant trucks.
Before they even get inside.
Before they even cross the threshold. A representative sample is pulled from each and every batch.
Okay.
And that sample goes through rigorous, very rapid testing right there. They're checking for precise things. Sugar content, again, super important. Moisture level, texture, or specific gravity which relates to starch.
So not just a quick look, but actual scientific tests on the spot.
Exactly, a scientific assessment at the point of entry.
So what happens if a batch doesn't meet those incredibly precise standards? Maybe the sugar's a bit too high or the texture is off. What do? Do they really just send an entire 50,000-pound truckload back?
That's precisely what can happen. If a batch doesn't meet the exact specifications set by the chip manufacturer, and they are very exact, it's either outright rejected,
Wow.
and sent straight back to the supplier, or sometimes it might be immediately rerouted for other uses, maybe animal feed, for example, where those
Right.
particular quality parameters aren't quite as critical.
Okay, so it doesn't necessarily go to waste, but it doesn't become a chip.
Exactly. This rigorous initial check is paramount. It stops substandard potatoes from ever even entering the main chip making line. And that's absolutely crucial for ensuring that unwavering product consistency that you expect when you open a bag.
Yeah.
Imagine, like you said, a whole truckload, tens of thousands of pounds of potatoes just turned away. It really highlights just how precise the requirements are for making that perfect chip. It's fascinating that even before any real processing starts, quality is just king.
It really speaks volumes, doesn't it?
Yeah.
Okay, so the potatoes have passed the tough initial quality check. They're deemed worthy.
They made the cut.
And they're finally ready to begin their transformation inside the factory. The very first step inside, our sources called it the wash and sort symphony. I like that image.
Yeah, it's fitting.
What does this initial purification process actually involve?
It really is a kind of automated spectacle, a complex dance of water and movement. So once they're accepted, the potatoes are basically dumped, pretty unceremoniously but efficiently, into these large hoppers. From there, they get nudged onto conveyor belts, starting their first real journey inside the factory. Their first stop is usually a high-pressure water flume system.
A flume, like a water slide for potatoes.
Sort of, but with purpose. This system is designed to blast off that initial layer of dirt, maybe small stones, any other debris that might have hitched a ride from the farm. Think of it like a powerful industrial pre-wash.
Got it. Getting the heavy stuff off first. And then, are they scrubbed by hand or is it more automation?
Oh, definitely more automation. After that initial flume rinse, they move into what's called a scrubber barrel. Picture a large rotating drum.
Okay.
It's specifically equipped with pretty robust water jets and brushes inside. These work together to give the potatoes a really thorough cleaning, scrubbing away any remaining dirt, especially on the skin.
Right.
So this multi-stage cleaning system makes sure absolutely no external contaminants get any further down the line. And it's not just cleaning. This stage often incorporates advanced optical sorters too.
Optical sorters, what are they looking for?
These are amazing machines. They use cameras and lights to instantly detect and then automatically remove any potatoes that might be misshapen or maybe have green spots or other blemishes that might have slipped through the initial checks.
Wow, technology is everywhere here.
It really is. It's a high-volume purification process, ensuring only the best, most uniform, cleanest potatoes move forward.
That's fascinating. An industrial level purification, just to make sure only the 18 potatoes make it through. Okay, so they're impeccably clean now. The next logical step is getting the skin off.
Usually, yes.
Except, as you mentioned, for some of those kettle chips or artisan styles.
Yeah.
How does this industrial peeling happen at such a massive scale? It can't be hand peelers.
Definitely not hand peelers. So these super clean potatoes are transferred into what are called steam peeling chambers.
Clean peeling.
Yeah. Inside these chambers, high-pressure steam is rapidly introduced. It's a very quick burst, just enough to quickly soften the potato's outer skin without actually cooking the potato flesh itself.
Ah, clever. Just loosens the skin.
Exactly. And once that skin is loosened by the steam, the potatoes move onto a mechanical system. Usually involves durable rubber rollers or sometimes abrasive brushes.
Okay.
These gently but effectively rub and agitate the potatoes, removing that softened skin. Any little stubborn bits left over are then quickly blasted off by targeted water sprays or sometimes powerful jets of air.
That sounds incredibly efficient. And I guess it minimizes potato loss compared to, say, just scraping it all off abrasively.
Absolutely. Steam peeling is known for being very efficient and reducing product loss, which is obviously important economically at this scale. It's gentle yet effective.
But, okay, you mentioned some chips like kettle cooked or maybe some fancier artisanal ones. They intentionally leave the skin on.
Correct.
So why the difference? Is it just for looks? Or does keeping the skin on fundamentally change the chip?
Oh, it's absolutely a deliberate choice, and it impacts both texture and flavor. It's not just cosmetic, although leaving the skin on does often give it a more rustic, kind of earthy look, which some brands warrant.
Right.
But more importantly, it can add a slightly earthier, more robust potato flavor. And maybe the biggest impact is on texture. Skin-on chips often result in a slightly chewier, heartier, sometimes more irregular crunch in the final product.
Interesting.
So while most mass-produced chips go for that uniform, lighter texture and look by taking the skin off completely,
Yeah.
this variation shows a clear, conscious decision by some makers to create a different product experience. For a specific consumer who likes that heartier bite, it really broadens the idea of what a potato chip can be.
That makes perfect sense.
Like
the
so.
design choice for a specific taste. Okay, so skin on or skin off, the next step has got to be the slicing. This feels like the pivotal moment, right? Where the potato truly becomes a chip in waiting.
It really is a crucial transformation point.
I can only imagine the precision needed here, doing this for millions and millions of chips every day.
The precision is truly one of the marvels of the whole process. So the clean potatoes, peeled or unpeeled, are fed into these highly sophisticated, high-speed rotating slicing machines. These machines have incredibly sharp, razor-sharp blades, really, that operate with astonishing accuracy. And the thickness of each slice. It's controlled down to fractions of a millimeter.
Fractions of a millimeter, really.
Absolutely. For your standard thin-cut chips, they're typically aiming for something like 1.2 to 1.4 millimeters thick, maybe even thinner sometimes.
That's incredibly thin.
It is. And for kettle chips, which we know are hardier,
Yeah.
they'll be sliced slightly thicker, maybe up to 1.8 millimeters, sometimes even 2 millimeters.
So that tiny difference, less than a millimeter, can radically change the final crunch and how the chip even cooks.
It absolutely dictates it. That minute precision is paramount for consistent frying time and critically for achieving that desired final texture. A thicker slice, like for kettle chips, holds more moisture internally,
Right.
which means it needs a longer cooking time, and that contributes to that denser, more substantial crunch they're known for. But what's even more crucial, and this is a really fascinating detail, is what happens immediately after slicing, like the instant they're cut.
What's that?
These delicate potato discs are instantly plunged into cold water.
Instantly.
Yeah.
Why the massive rush there? Is it like a race against time? Or are they trying to stop some chemical reaction?
It's both, really. A race against time and against potato chemistry. This immediate cold water bath serves two absolutely vital purposes.
Okay, what are they?
First, it stops oxidation. Just like an apple slice turns brown when you cut it and expose it to air.
Yeah.
Potato slices would do the same very quickly. The cold water stops that browning, keeping the chips looking visually appealing, that nice pale color.
Makes sense. And the second reason?
Equally important, it washes away excess surface starch. If that sticky starch was left on the slices, they could clump together during frying.
Big chip blob.
Exactly, nobody wants that. Or it could result in an undesirable texture in the final chip, maybe gummy or sort of chalky. And our sources also mention that some manufacturers even take it a step further. They might pass the slices through, say, sugar water or maybe a citric acid solution.
Why would they do that?
It provides even more protection against discoloration, ensuring they stay perfectly pale before they hit the hot oil. It's a direct, precise chemical intervention, all about ensuring those chips look pristine.
That's amazing. They're literally engineering the perfect outcome from the very first second the chip is sliced. Okay, so these perfectly sliced, non-browned, destarched potato discs are now ready for their big moment. But wait, before the oil, there's another step you mentioned, dewatering.
Yes, absolutely critical.
This seems like it would be incredibly important. Why?
It is perhaps one of the most critical steps right before frying. It's a detail consumers probably never think about, but manufacturers manage it meticulously. So after the slicing and that final cold water rinse,
Yeah.
the chips are passed through high-speed centrifuges, think like a giant salad spinner or sometimes across vibrating mesh screens.
And the goal is just to get the water off.
Exactly. These machines are engineered to sling off or shake off as much of that surface water as physically possible from every single slice.
And why is this step so profoundly crucial before they hit that hot fryer? What would happen if they skipped it or didn't do it well enough? I mean, water and hot oil. It sounds like a bad combination.
You've nailed the fundamental problem right there. Water and hot oil do not mix well. It's basic physics, basic thermodynamics.
Right. Explosions.
Well, maybe not explosions, but definitely violent splattering in that super hot oil. That's dangerous for equipment, for people, but it's also really inefficient. Causes way too much oil to be used up or degraded.
Okay.
But even more importantly, for the chip itself, if you have water left on the surface, it leads to incredibly uneven cooking. Those chips would come out soggy, limp, inconsistently fried, basically ruined.
The dreaded soggy chip.
Exactly. So by removing virtually all that surface water, manufacturers save a lot on oil, costs a huge factor at the scale, and most importantly, they ensure incredibly even, consistent cooking. That leads directly to that signature crispness. It's like, prepping for a high-stakes cooking experiment. Every single drop of water you remove beforehand matters for getting that perfect, uniform result.
That makes perfect sense. Get rid of the water, set yourself up for the perfect crunch.
Yeah.
Okay, so these perfectly de-watered slices are finally ready for the main event, the fry.
The golden transformation.
This is where the magic happens, right?
Yeah.
The transformation from a pale potato slice into the iconic chip. How does this work on such a massive industrial scale?
This is really the heart of the crunch creation zone. So the prep slices enter what's called a continuous frying system. Picture a very long, narrow stainless steel tank. It can be many, many meters long. And it's filled with intensely hot oil, usually a stable, neutral flavored oil like sunflower or corn or canola oil. And that oil is kept at a very precise temperature, typically right around 350 degrees Fahrenheit. That's about 175 Celsius.
And the chips just float through this river of hot oil. How do they make sure every single chip cooks evenly?
They don't just float freely, no. That would lead to clumping and unevenness. Instead, the slices are submerged onto a moving, perforated conveyor belt that travels through the oil.
A conveyor belt in the oil.
Exactly. This belt is crucial. It keeps the slices flat, stops them from sticking together, and moves them steadily and uniformly through that hot oil from one end to the other.
And how long does this take?
It's remarkably fast. The actual frying time is typically only about 2 to 3 minutes.
That's it, 2 to 3 minutes.
That's it. And what's truly amazing is the almost instantaneous transformation that happens in those few minutes. The water that's inside the potato slices rapidly evaporates. It basically boils out of the potato structure,
Right.
leaving behind this porous, crisp, golden chip structure. As they fry, they're also gently agitated, maybe by paddles or the movement of the oil itself, just to make absolutely sure nothing sticks together.
Okay.
And then as they exit this river of oil, any excess surface oil is swiftly removed. First, by vibrating mesh screens that let the oil drip off.
Yeah.
And then often further removed by powerful air knives. These are basically just strong, focused jets of air that literally blow off any remaining surface oil.
Air knives, wow.
Yeah. So this whole high-speed, precisely controlled environment, that's what delivers that consistent, uniform, and pretty addictive crunch we all know. It's not just frying, it's really a rapid, controlled dehydration process that fundamentally transforms that potato slice.
It's just astounding to think that in just a couple of minutes, that radical change happens for millions of chips all flowing through. Okay, once they're perfectly golden and crisp, then comes the flavor.
Yes, the seasoning stage.
This is where we get all those amazing varieties. Classic salt, tangy BBQ, sour cream and onion, all that good stuff.
Right.
But how do they actually get the seasoning to stick so perfectly and evenly to every single chip? That seems like it would be a challenge.
It's another one of those marvels of engineering and precise timing. The key is that this happens while the chips are still warm from the fryer. That warmth is absolutely crucial.
Okay, warm chips.
So the warm chips are transported, usually via a conveyor belt again, into these large rotating tumbling drums, or sometimes specialized flavor applicators.
Rumbling drums, like giant cement mixers full of chips.
Kind of like that, yeah. And inside these drums, the dry seasonings, the salt, the BBQ powder, cheese powder, whatever it is, are meticulously sprayed or sometimes shaken onto the chips as they gently tumble over and over.
So the heat and maybe the little bit of oil left on the chip helps the seasoning stick, like a natural glue.
Exactly. That slight residual warmth and the thin layer of oil still on the freshly fried chips create the perfect surface for those dry seasonings to adhere to. It ensures they don't just fall off.
Makes sense?
And for some chips that use liquid flavorings, maybe for a stronger coating or a different kind of flavor profile, those liquids are sprayed onto the chips using incredibly precise nozzles, ensuring a very even, consistent application.
Right.
And that continuous tumbling action inside the drums, that's absolutely vital. It ensures that every single chip gets a consistent, even coating of seasoning, from edge to edge. This careful distribution is critical for flavor uniformity in the bag and ultimately for keeping consumers happy. This is truly where the magic of flavor happens, moving beyond just a perfectly fried potato to a specific, delightful taste.
Okay, so now we've got these perfectly crispy, perfectly seasoned chips.
Yeah.
But they're still warm.
Still warm. Yeah.
And you can't just throw warm chips into a sealed bag, can you? I feel like that would lead to problems, soggy problems.
You are exactly right. That would be disastrous.
So there must be a crucial cooling step next for both crispness and, shelf life.
Absolutely. This is a vital, though maybe less glamorous step, but it's essential for maintaining quality and making sure the chips last. So after seasoning, the warm chips are rapidly transported, usually on air-blown conveyors or through dedicated cooling tunnels.
Okay, just blowing cool air on them.
Essentially, yes. The main goal here is just to bring them down to room temperature as quickly and efficiently as possible.
And why is that so critical? What happens if they do package them while they're still warm? You mentioned sogginess.
You've hit the nail on the head.
Yeah.
This step is absolutely essential to prevent condensation from forming inside the package. Think about it. If you seal warm chips in a bag,
Yeah.
the temperature difference between the warm chips and the cooler air inside the bag and eventually the outside environment will cause moisture to evaporate from the chips and then condense on the inside surfaces of the bag. Little water droplets.
Yeah.
And that condensation leads directly to soggy chips, ruins the texture completely. Even worse, that trapped moisture creates the perfect environment for mold to grow.
Oh, definitely don't want that.
No. So, cooling is critical for locking in that crispness we just achieved and for significantly extending the chip's shelf life. It's a careful race against time, yes, but also a meticulous control against humidity, making sure that crispness is preserved all the way from the factory to your pantry.
That makes so much sense. Nobody, absolutely nobody, wants a soggy or worse, moldy chip.
Okay. And speaking of ensuring a perfect chip, even after all these intricate steps, the washing, peeling, slicing, frying, seasoning, cooling, there's still a really serious quality assurance process. Right?
Oh, yeah, it doesn't stop.
I'm picturing sophisticated robot eyes scanning everything, but maybe people looking too.
It's exactly that kind of multi-layered approach. It's really thorough, and it's what ensures that brand consistency and, frankly, consumer trust.
Yeah.
So once the chips are cooled, they typically pass under these incredibly sophisticated optical sensors first.
Robot eyes, basically.
Pretty much. These sensors are remarkably advanced. They can instantly detect any chips that might be slightly burnt or broken or have an odd color that doesn't meet the exact brand standard.
But in parallel with that, you also have human workers stationed at various checkpoints along the line. They perform manual inspections.
So people are still involved.
Definitely. They act as a final visual check, catching anything the machines might have missed or maybe confirming an anomaly the machine flagged. It's that combination of, AI precision and human judgment that creates a really robust safety net.
And it's not just about how they look, is it? Our sources mentioned there's more scientific analytical testing happening too.
Absolutely. It goes beyond just visuals. Very importantly, metal detectors are strategically placed at various points, usually just before packaging. This is to catch any potential tiny metallic contaminants, a critical food safety step.
Non-negotiable, I imagine.
Absolutely non-negotiable. And then, yes, random samples are continually pulled off the line. They go to a dedicated lab right there in the factory, usually.
And what are they testing in the lab?
They're looking for incredibly precise measurements, things like moisture content that needs to be under a critical threshold, usually below 2%, for optimal crispness and shelf life.
Wow, under 2% water level.
Yeah, very dry. They also check oil content, which affects texture and mouthfeel. Color uniformity, again, making sure it meets the standard. And of course, they do critical sensory testing. Trained panels assessing crispness and taste.
People actually taste test them regularly.
Absolutely. This whole multi-layered quality control system,
Right.
the optical scanners, the human inspectors, the metal detectors, the lab test, it all works together to ensure that only perfect chips make it into the bag.
Right.
It protects the brand's reputation, it ensures consumer safety, and most importantly, it maintains that product consistency bag after bag, year after year. What's really fascinating is how the precision of automation works hand in hand with the nuance of human inspection and that hard analytical data. It's an intricate system of checks and balances, truly a testament to delivering a uniform product you can rely on.
And it's just astounding. All that detailed science, all that engineering, that sheer dedication, just for something we grab off a shelf for a quick snack. Okay, finally, the moment of truth. packaging.
Bagging time.
This is where the chip gets its signature. Poof, in the bag. I've always wondered about that. What is the deal with all the air in a chip bag? Is it just empty space to make the bag look bigger? Or is there actually a reason for it?
The famous air in the chip bag is probably one of the most common consumer questions, right?
Totally.
And yes, there's a very scientific and very practical reason for it. It's definitely not just empty space. So after the chips pass all those rigorous quality checks, they're precisely dropped into something called a multi-head weigher. This is a fantastic piece of engineering in itself. It uses multiple little buckets to calculate and dispense the exact right weight of chips for each bag.
So that's how they get the weight spot on.
Exactly.
Yeah.
Whether it's a tiny 1-ounce snack size or a 2.5-ounce bag or a big family size one. The bags themselves are usually formed right there on the machine, created on the fly from a big roll of pre-printed plastic film. It gets formed into a pouch filled with the weighed chips and then sealed using heat and pressure.
Okay, makes sense. But then comes the puffiness. Our sources specifically mention nitrogen gas being injected just before sealing.
Correct.
What's the actual purpose of that? Is it just air, like from an air hose, or is it really this special gas that keeps them fresh?
It is absolutely a crucial, non-negotiable step, and it is definitely not just air. Just before that final seal is made on the bag, nitrogen gas is flushed into it.
Nitrogen. Okay, why nitrogen?
The main reason is to displace oxygen. Oxygen, you see, is the arch enemy of freshness for snacks like potato chips.
Right, makes things go stale.
Exactly. Oxygen causes the chips to go stale much faster. It can also lead to the oxidation of the oils in the chips, which gives them that unpleasant, rancid flavor over time. So by flushing out almost all the oxygen and replacing it with inert nitrogen, meaning it's a non-reactive gas, it doesn't cause these spoilage reactions.
Yeah.
The shelf life of the chips is significantly extended. It keeps them fresh, crisp, and tasting the way they should for much, much longer.
Okay, so freshness is key.
Yeah.
But does it do anything else?
Yes. It has a second, very important function. That cushion of nitrogen gas also acts as physical protection for the very delicate chips during shipping and handling.
Like bubble wrap.
Exactly like edible bubble wrap. It prevents them from getting crushed and crumbling into tiny pieces before they even reach the store shelf, let alone your home. It ensures you actually get intact, satisfying chips, not just a bag of crumbs.
So, wow. Okay, that puffy chip bag isn't just full of air at all. It's actually this sophisticated delivery system.
Yeah.
Designed to protect your snack from going stale and from breaking.
Precisely. A dual-purpose protective bubble.
That is kind of genius, actually. And then once they're sealed up in their nitrogen cushion, each bag gets date stamped, coded for traceability, all that stuff.
Yep, all the tracking info is added.
And then they're finally ready. Boxed up, put on pallets, wrapped, sent off to distribution centers and stores. And the whole thing, from a potato being harvested to ending up in that sealed bag, can take as little as, 24 to 36 hours?
Sometimes, yes. For some highly optimized operations, it can be incredibly fast.
That is just an unbelievably rapid turnaround for such a complex product with so many steps.
It truly is an astonishing feat of modern manufacturing. The sheer efficiency and speed, combined with that rigorous quality control at every single point, that's what allows for this massive global supply of consistently good potato chips. It's a real testament to optimized industrial processes.
Absolutely. Now, okay, before we wrap up this deep dive, we've talked mostly about the classic, thin, continuously fried, crispy chips.
The standard bearer.
Right. But there's so many variations out there now. Our sources mentioned kettle-cooked chips, and even baked chips are those perfectly uniform engineered shapes that don't even start as a whole sliced potato. How do they differ in their journey? Are they going through completely different processes?
Yeah, those variations represent pretty significant departures from that continuous frying process we spent most of our time detailing. Let's take kettle-cooked chips first.
Okay.
While regular chips go through that long, continuous fryer.
Yeah, the river of oil.
Right. Kettle-cooked chips are made in what are called batch fryers. It's a totally different approach. The potato slices are cooked in smaller, discrete batches within the oil.
Smaller batches.
Yeah. And importantly, they're often stirred either manually by someone with a big rake-like tool or sometimes mechanically, but still in that batch. And crucially, they're typically fried at lower oil temperatures, but for a longer time compared to continuous frying.
So it's a slower, more deliberate, almost more artisanal approach. Is that what gives them that characteristic thicker, harder, maybe more irregular crunch that people associate with kettle chips?
That's exactly it. The slower batch frying process, combined with the lower temperature and often slightly thicker slices, allows for a different kind of moisture removal from the potato slice. More gradual, and this results in their characteristic texture thicker, harder, often more irregular, sometimes with more bubbles or folds. It distinguishes them very clearly from the continuously fried, thinner chips. It's a deliberate process choice, trading speed for that unique textural experience, that specific hearty mouthfeel that kettle chip fans love.
Okay, that makes sense. Different process, different texture. And then what about baked chips? Often sold as a healthier option. And those perfectly uniform chips, the ones that stack perfectly in a can, how do those fit into the potato chip universe?
Right, so baked chips, well, as the name implies, they skip the frying process altogether.
No oil bath.
No oil bath. They require a completely different manufacturing setup. Primarily, they need a large baking tunnel system where the potato slices, or sometimes potato dough, are cooked using intensely hot air instead of oil.
So it's more like making crackers or something.
Kind of, yeah. It fundamentally changes their fat content, obviously, and as a result, their texture. Baked chips tend to be lighter, maybe crispier in a different way, but they don't have that same rich, fatty crunch you get from frying.
So essentially a completely different factory line needed, and really a very different end product. And those uniform chips, the stackable ones, those are maybe the most intriguing to me. They don't look like they came from a potato slice.
That's because often they didn't. Those are perhaps the most radically different in how they start. Some chips, particularly those perfectly uniform stackable ones,
Right.
aren't made from slicing whole potatoes at all. Instead, they're engineered from a dehydrated potato slurry. Think of it like a potato paste or a dough made from potato flakes and water and other ingredients.
Well, okay, potato dough.
Yeah. And this dough is then precisely rolled out thin, cut into those perfect uniform shapes using a mold or a cutter, and then these shapes are either baked or sometimes briefly fried to give them crispness and color.
So it's a complete departure from agriculture straight into advanced food engineering almost.
That's a great way to put it. It fundamentally changes the raw material and the entire manufacturing process.
Which raises a really interesting question, doesn't it? Like, what exactly is a potato chip if it doesn't even start as a sliced potato?
Right?
It really broadens our whole understanding of what's possible in snack food engineering. It shows how innovation can create entirely new product categories, really, even from familiar ingredients like potatoes.
It absolutely does. It showcases the incredible innovation and versatility within the snack food industry. It allows manufacturers to create totally different textures, those perfectly uniform shapes for packaging and dipping, and often, yes, alternatives that might be perceived as healthier, all to meet diverse consumer demands and preferences. It really moves beyond the traditional idea of just slicing and frying a potato and highlights how food science can engineer entirely new eating experiences.
Wow, okay. So we've gone all the way from a very specific type of potato grown in a particular way, stored in a special climate-controlled environment, put through rigorous gate checks, multi-stage cleaning, incredibly precise slicing, that critical dewatering step, the rapid golden fry, meticulous seasoning, careful cooling, intense quality checks, and finally into that protective nitrogen-filled bag.
Quite the journey.
It is truly an incredible, intricate, high-speed journey for something that, let's be honest, we often take completely for granted.
It truly is. I think this deep dive has really shown us that creating that perfect, crispy bite of a potato chip is just, well, it's far more complex than whipping up a batch in your kitchen.
Way more complex.
It's a remarkable high-speed ballet of agriculture, chemistry, complex engineering, and incredibly sophisticated logistics, all working together in harmony at a massive global scale. The aha moments here are definitely plentiful. It genuinely makes you appreciate the sheer science and effort behind even the simplest seeming snack.
Absolutely. So maybe the next time you open a bag of chips, and let's face it, there probably will be a next time.
Probably.
Just take a second to consider the remarkable balance of farming, science, engineering, and logistics that went into creating that perfect crispy bite you're about to enjoy.
Well said.
And maybe that leaves us with a final provocative thought for you, the listener. What other everyday items do you think hide such a complex and surprising journey, from raw material to finished product? What simple thing do you use or consume every day that might actually be a hidden marvel of modern industry? Something to maybe mull over next time you're reaching for a snack.